I am Dan Funk, CEO of Spiffworks. My company is focused on reducing the opacity of technology and improving communication between people. We do this with a tool called BPMN, Business Process Model and Notation. This talk is going to use a very small bit of BPMN and our tool Spiff Workflow. It is really designed to help everyone understand a little bit more about how LLMs work. So today we're going to dissect an LLM. I have one here. I have, let's see if I can get this on the camera. I've got the LLM, the neural net is there. You can see it kind of spawning around the creature. We've got a mothball here, and I'm gonna like stick it in there and anesthetize the poor critter so that we can pull this strange creature out of this formaldehyde in a minute and have a look at it up close and personal. And then you can get your hands dirty. I'll be here in front of you doing it as a demonstration, but you can be doing the same thing on your own computer. You're literally going to open this thing up. We're going to talk about its evolution. We're going to stimulate its muscles. We're going to see it flex. We're going to get a clear understanding of exactly how it works. And we'll do this in the context of its application to health. I think that's a really interesting domain to apply AI. Like, does it make decisions? How does it, what is it doing there? So let's think about that for a second. Is it safe to exercise? And we'll take it like it seems like a benign question. Is it safe to exercise outside right now? And look at how an LLM handles this question. Along the way, I hope we kind of take some of the mystery and the magic out of all this, but that we also find some awe and see some of the beauty inside these like really incredible computational systems. Yeah, let's start out. So getting our tools together, for this dissection, we're going to be using a tool called BPMN. Stands for Business Process Model and Notation. The first thing that you should notice is that you understand this diagram already. It's based on a flowchart notation that almost everyone has seen on a whiteboard somewhere. We're going to build this diagram out step by step and make it more complex as a part of this lab. So everything I do in front of you today, you can do as well. The goal of our brief time together is to build up a set of examples that will help clarify what an LLM is and give you some tools for how to think about them. If we can understand these tools better, we'll be able to apply them more skillfully, whether that's at home, in talking to our kids, in doing them at business, and most importantly, like doing them in health or in legislation, places where we could be building up laws and setting things in motion or changing people's lives. We really need to understand how these tools work to see like what the impact of that might be. I think first and foremost, I want to be clear, it is really a dangerous and bad thing to start to anthropomorphize or, to treat these machines like they are human beings. They're not. If you take nothing else away from this talk, please know that an LLM is not conscious. It is not self-aware. It is not processing feelings. It's not even trying to simulate feelings. All it can really do is generate a very accurate simulation of new content based on the content on what it was trained. That is mostly web pages. So if you look at just looking all the way down at the lowest level, looking at a neuron, on the left here, you can see like a human neuron, and it's deep and complex and beautiful and delightful. It is so interesting in its capabilities and the way it functions. And we're comparing that to an artificial neuron, which is amazing. It's a stunning thing, but it's just a set of simple functions, a simple transfer function, a simple activation function, and a set of weights. I mean, we're taking this simple structure and we're combining it in ways that somewhat simulate the nets that information travels through in our minds, but it's no way the same thing that it's going through. These are apples and oranges. These are vastly different systems. So even in a brave new future where AI continues to get more and more and more capable, it's never going to behave like a human does. And you should just think that way. Get that in your head. All right. So the way we're going to start this first lab, like talking about the base model. So when you hear people talk about, say that LLMs take months to train, or 10 million gallons of water, or like enough electricity to power whatever, like the all that giant effort is in building something called a base model. And it's this base model that mostly feeds on the internet. They curate the best content on the internet, and things that take all these things that are considered very, very high quality sources. And those might be more than just the internet. It could be books and articles and papers, but it's anything that they can go out there on the internet and scrape in large part is what builds these base models up. And the results is a large statistical algorithm that's good at one thing, and that is like predicting the next set of words. It uses a vast neural network. It uses something called attention to sort of find like the important words and give them more weight. And then it suggests the next thing that's most likely to occur based on the data. So the way they train a neural net is they give it some information and they ask it to make a prediction. And the better it gets at predicting what the next chunk of text would have been on the internet, like the closer that matches the training data that they gave it, the like this back propagation kind of builds that. They use that to like build up this net of the statistical model, that will make those predictions. That's what a base model is. That's what an LLM is. And so we've got this really nice visualization that's out there, and I strongly urge you to check it out. This little diagram here, that we can zoom in on, and actually we can do that through here. We can it's got like a nice tutorial that brings you back in. And this example is going to walk you through like a very simple system, and all it can do is tokenize like the letters A, B, and C, and start working through to sort those three letters. That's really all this like neural net does here. This nano GPT, it sorts letters into the right order, predicts like that B should come after A in all cases, and so on. What you can do with this excellent tutorial is kind of see how this LLM thinks, how this data moves through its neurons, and how that controls like the output that it produces at the end. And then you can start to look at how it compares to, like this nano model compares to like ChatGPT and what it's doing, or like the new iterations of it that are getting larger, and GPT-3 is on here that gets larger. So it's really kind of applying. What's nice is you can look at this like very simple example here and step through these steps and really get a good sense of like how data moves through these systems. So highly recommend this link. So let's go back to our lab here. And so lab one is going to be like looking at this base model. And like, I guess like, yeah, the big takeaway from this lab, what you're going to see is you can't talk to a base model. So that weird thing where you seems like you're having a conversation with a machine, you can't do that with a base model. Even though the base models were 90%, 99% of the effort goes into generating this thing, this is all you get. So here's the URL, we're just going to follow it. This is going to take us to the tool that my team created. So this is called SpiffWorks, and it's a BPMN diagramming tool. So these look like flowcharts, and we're going to focus in on this very first diagram here. Is it safe for me to exercise today? So I'm going to, like, when you're doing this, what you want to do is make sure that the diagram that's on here that you want to run has a start element. So I'm just going to drag this, do that again real quick just to be clear. I'm just going to take this little circle. This is a start event in BPMN, and I'm going to grab an arrow and I'm going to bring it over and connect it. So that says start here, and then do this step, and then this step, and then this step, and then stop. And so what are these three steps that it's taking? This is going to get a little technical, but you do not need to be technical to kind of follow along. I'm just going to open this up. This is a little Python script that runs. And what this does is it's going to set some variables. And those variables are what URL we want this thing to go to. So what place on the internet. We're going to use this thing called hyperbolic, which gives us access to LLMs. A whole bunch of different LLMs, because we could talk to all kinds of different LLMs on it. And some headers. This is basically like how you log in. So this is going to give it the username and password, basically, that says I paid the $20 so I could get in here. And we're going to send it some data. And the most interesting things about the data are this prompt Is it safe for me to exercise outside today? So it's exactly what you would type into ChatGPT, and then a model. And here we're going to use Meta's Llama model, but we're going to use one that's a base model. So this is not one that's seen any post-training. And we'll get to post-training in a second. I just want you to see what the core of these systems are. You know, when you peel the skin back, when you look down at the organs, what is this thing actually doing? How do these things work? This is, you're looking inside the creature. So I'm going to save and close that. So this is a script. This is a service task. That's what those gears are. And what service tasks do is they just make API calls. So it's going to go out and call the URL with the headers and the data. So all the variables that we set up here, this is going to use it. It's going to make a call out, and then it's going to process the result that comes back. So the result's going to come back into something called an API response, and we're just going to look down inside that response to get the message, that the text of the message that this is what, you know, this is what the LLM said back. And then this is, you know, what we're just going to display it. So this is the way in our BPMN tool, Spiff works, that would present a message. So let's run this thing. So I'm going to come up here and hit play, and it's going to go blast right through that, right? That's just a very simple Python script that takes no time. Then it like goes out and does it. So we said, should I go outside and exercise today? Does it answer the question? No. It says, should I take my rescue inhaler with me? These are questions patients with asthma often. It's starting to respond to you just like it would if you were, this is the most likely set of sentences, or a highly likely set of sentences that you would find on the internet if like the first line in the article was that, right? So if that was the title of a blog post, that's the content you would see. And that's how this LLM responds. And it's going to, because like there's many blog posts out there talking about health. I mean, how many? It's going to be pretty randomly seeming, like it's going to come up with a lot of different solutions to this, right? Another like likely way to respond to this is, how about my kids? When should I go for a run, a walk around the block, a bike ride, hike, So off it goes, generating another blog post about this topic. Do it again, it's going to do the same thing. It's never going to answer the question, should I run that air conditioner? These are the questions that asthma sufferers, wait, blah, blah, blah. So it's an asthma article now. Very like sort of seemingly random, because it's a pretty open-ended question, and it's a highly likely question to occur on the internet. So there's going to be lots of potential responses to it. It's a stochastic system, meaning it's unpredictable. It's not deterministic. It's not going to always return the same results, mostly. So let's come back to that. But there's your base model. This is what all the effort goes into training. So why does it answer questions? Why, when you, if it's really just spitting out what it was trained on the internet, why does it respond to us like it's talking to us? What is going on there? The way that like, and there's the way that they did that, certainly if you go back to like ChatGPT 2 and like the papers that were published around that, if you look, the way that they did it was they went out to Upwork and other services like that, and they hired people, a lot of experts, and they said, here's the way that we want you to write what it basically amounts to a script. Like, think of a movie script, and we want you to always have two actors. There's a user actor, and that user actor asks questions, and there's an assistant. That assistant is kind, they're patient, they are authoritative, they really understand what they're saying, and they respond to these questions that come in, or these statements that come in, and talk in a conversational tone. Question, answer, user assistant. And this post-training on these like 100,000 or, you know, however many, this post-training that comes back, they build up this post-training, and then they use that to do like a final training on the model. And this is not 10 million gallons of water. This is not 3 months and 5 million processors. What you're talking about here is just a few hours of post-training to establish a pattern. And then whenever you start typing stuff in to tools like ChatGPT or any of the other like chatbots that are out there, when you post that, what gets sent to the LLM is like user It comes down to assistant : and it stops. And it says, now LLM, predict what would happen next. And so of course the LLM is going to predict what, you know, An assistant would start to say it because it's seen that pattern 100,000 times. And it's probably seen it in this specific case of like when somebody specifically asks, when is it safe to exercise outside? Or when is it safe for me to exercise outside? Like, here's the response that you get back. So let's look at that. Um, so I'm going to come back over to the example here and reset. I'm just going to like take this guy here and we're gonna bring it down and have it talk to this next model. Let me just zoom out a little bit here so that you can see it. And so there's the first one, and here's the second one. It looks identical. There's really no difference. The only thing that we've changed here is the model is no longer that base model B. It is that base model dash instruct. This is an instruct model. This has seen some supervised fine tuning. And so it's going to answer questions the right way because it's seen hundreds of thousands of examples of how you answer questions. So this model is going to behave differently. Same base model, same training, all the same stuff, just a layer on top of it, just some fine tuning to get it to behave a little bit more, to match the patterns a little bit more to what we're used to seeing. And man, I hope this thing picks up. There we go. Oh, wow. The response is, to determine if it's safe to exercise outside today, I need to know your location and current weather conditions. And then it lists off in like this bullet form: weather, air quality, sun protection, other factors. Wow, this is really informed. This is really well thought out. Why is this so well thought out? You know how like when we did it first, like the first time we ran through these things, it was very random because there's lots of blog posts about health out there. So we kept getting these very different responses each time. Is that still true? What happens if we play this again? Let's reset it, play it again. Be patient. Dan, very patient. So it's going to sit out there. It's going to pull this data back, but it's going to be, if it ever comes back, it's going to be kind of the same response. And that's because it was very trained on the data about how to answer this question. It was trained and trained and trained. So almost like what they would call overtraining. Like it's been overset so that it's going to pretty much respond identically over and over and over again. So it doesn't matter how many times I run this thing is going to come back with largely the same result, because it's not coming back with something it came up with. It's coming back with the response it was trained to come back with. So that's why it's consistent. That's why it looks like this. That's why it's always going to look like this, is because it was overtrained on these questions. All right, so let's move on to the next one. So that was kind of the supervised fine tuning. People do it. People create those answers and responses. It's not always going to be exactly verbatim word for word, but it's always going to be very close because they've been so strongly trained on how to answer these questions and how to have these conversations. So like the next is like how does it carry on long-term conversations, right? If it's just auto-completing blog posts or auto-completing web pages, and then like has this kind of layer on top of it that's telling it like what that feels like to have a conversation. So why does it seem to know about me? Why can I go to ChatGPT right now and say, tell me about me and why I'm wonderful, and like what things have you like learned about me, and like how, you know, what things could I correct about myself? And it comes back with these really detailed, intense responses, like what's going on there. Well, that's just a loop. It's just a loop. Instead of like that script being user assistant, some of like what it's being trained on is an ongoing conversation of user assistant, user assistant, user assistant. And so it can start to like build up that conversation. And so each time you're prompting that AI, you're not prompting it with just the latest thing that you have to say, and it's remembering you and caring about you and everybody else on the planet. It's not that it's doing that. It's that the whole conversation, or some summarization, you know, depending, But pretty much that whole conversation is really just kind of getting fed right back into it again. So the next time the LLM hears from you, it doesn't hear like, okay, like yes, you're in Richmond and like you're doing this, so I think like this would be a safe exercise for you to do. It's not like thinking about that. It got the whole thing. It got the whole conversation all over again, and it's predicting what the assistant would say after, based on all of the stuff that you've ever said to it ever, for as long as this loop is going on. So let's watch that run. And so for that, I'm just going to reset it. I'm going to bring another line down, and we're going to watch this loop run. So hit play here. It's going to take that same question. That's identical. Asking the AI, that's identical. Instead of presenting the results, just presenting the results, it's going to give us a little prompt down here so we can add more information. So I need to know the location and the current weather conditions. However, I can provide you, same thing over again. So here, let's say I am in Stanton, Virginia. That's my hometown. And so I'm just going to submit that. And then what it did, it's a little hard to notice, but like what happened was it went to this gateway here and it went back up this loop and it sent all the information back into the AI again. And so now the AI is processing a much larger prompt. And this is where you get into context windows, if you've ever heard of that, if it gets kind of technical. So context windows are that. Like it's just this ever increasing window of content and information that's gone back and forth between you and the LLM. And now it's responding intelligently because it understands that I'm in Stanton, Virginia, and it's going to go and check the temperature. And hey, the temperature's around 58 degrees Fahrenheit. Well, how did the LLM know that? You know, it didn't. It's responding as of current weather conditions as of my knowledge cutoff. So it's trying to like inject some stuff here. They're working on it. But it's responding, with the most likely set of words that you would respond to here. It doesn't know what the temperature is here. It's definitely not 58 degrees. It's like a nice 73. I don't know. I think it's a light breeze, but it's just randomly accurate because it doesn't know. Does not know the forecast for today. This is like, it was trained to like fill in the blanks for this stuff. It just doesn't have the information to do it. And so it, I guess like the way people would say it hallucinated, but it didn't hallucinate. It does nothing but hallucinate. It does nothing but generate the most likely words. It's not thinking through this. It doesn't have some model of how the universe works inside of this neural net. It knows how words work. That's what it's modeled. And this is the way words work. And this is the pattern that you would respond to in this way. So it's presenting that pattern. If you wanted to know what the pattern is, it's going to do a very good job. If you're going to know what the truth is, well, you need to look somewhere else. And we can continue to iterate this. I can start to change my mind and tell them I'm somewhere else. But like the important thing to take away from that is this loop. This is just a loop. It's doing the same thing as all of the other things that I showed you. It's just looping back around and sending more information in each time. And each time that additional information changes the response of the AI. So the important thing here, I guess, one of the things I'd most like for you to take away is you should control this loop. This should not be hidden from you. This shouldn't be behind the curtain. You should know exactly what is being collected about you and what's being sent back in. That loop you should control it. You should know what it is. You should have complete access to it. All right. So back to this. So we've got a fourth lab. And here it's I want to start talking about tools. So like, if you're out there and you're building these things and you're like, I want people to, to pay me lots of money, and I want people to be amazed by how great this tool is, how great LLMs are. And I have this problem that it's just going to continue to lie. It's going to try and fill out. It's not going to lie. It's not going to hallucinate. It's just going to continue to produce content. And somebody's going to say, but I expect that content to be true. And they're like, oh, well, how do we make it more true? How do we push more truth into it? How do we give the LLM more information so it makes a more accurate prediction about what an assistant would say? Is really what it comes down to. And so what you can do with those scripts is, rather than just be user assistant, you can start to add in things like, oh, and there's a tool, and you can call the tool like this and pass in this information, and the tool will return this. And you can build up those patterns with that post training. Let's supervise post training to start to alter this so that it is aware of tools, and then you can make those tools available to it. So let's look at that model. So that's down here. I'm just going to quickly delete this thing and bring it in here, and we'll step through this one time. So still the same setup. Basically, we're gonna come in and set this up, but we're gonna give it just a little bit more information. So we've got our basically our login information up here. We're going to be talking to Gemini this time, and because this is one that's seen post training that's helped it understand how it might talk to a tool as well as a user and an assistant. And in that tool definition, we've got a name and a description and parameters. So we're telling it like this tool's called web search. It can search the web and to find information like the Latin long for a place name or current events or so on and so forth. So we give it some context there around the description of what this tool is and tell it parameters like and it's pretty simple, like it's just search. So search augmented, RAG, sort of a RAG based system is basically what we're building here. And if we go back and slide out, we'll see that so we set up those variables. This is still exactly the same. It's just going to make that API call out. But when it comes back, we're going to look just to really dig in here so you see every bit of this. We're going to parse this response and check to see if instead of it saying assistant said this, it's going to say do a tool call, and the tool call should do something, and so it's just gonna make that basically it's gonna say I want to do a function call based off of how I was trained. I would the logical next thing to do, or the predicted next thing to do would be a function call. And so we're just kind of all this is just a little bit of Python to pull out what that function call's name and arguments are. And if we encounter that in that post thing, then when we get to this gateway, we're going to go this way. And the condition that we do this is, hey, there's tool info in the response, and that tool info is a web search. And so we're going to if that's true, we're going to go down this path. If it's not true, we'll just go and open the prompt back up to the person. And now if we hit play, we're going to send that initial question off to the AI and wait patiently. And it's aware it's got a tool. So in this circumstance, if it's aware it's got a tool, the assistant is going to respond. They've trained it this way, that the assistant would respond to actually ask a question. Could you please let me know where you are? And let's go ahead and be in Stanton, Virginia, because I know precisely, I know what temperature it is out there. And now it went through the loop. It went through talking to me. It went back around. It sent it to the AI. It came down. It searched the web. And so now, and I'm sorry this is so jumbled, but this is the context. So the user said, is it safe to exercise outside today? And the assistant asked the question, where are we? The user said Stanton, Virginia. The assistant didn't say anything, but said I want to use a tool. And so the tool then injects a search. It runs the search, and it just kind of blasts out all of this content to this LLM. The LLM can't read this a whole lot. It's not reading this in any special way. It's just it's reading it just like you would. So it's saying the title, weather in Stanton, Virginia. The URL is weatherapi.com. The content, location, name, here's the Latin long, local time, last epoch. So it's coming down here. It's going to eventually provide us it feels like 26.3 degrees Fahrenheit, 79.4 degrees. So all this is information that just came back from this thing, and it looks pretty good. So I can what's handy is, yeah, it's a little technical, but I can kind of dig in here and see, oh, this is the search results that it got back from a website. And it looks like it found a good website And it shows wisely about how to get this information back. It's kind of interesting because I think if I type this into Google, I would hit more advertisements than I would hit like the weatherapi.com. So it knew the right it knew the right one to hit on, which is interesting. So assistant says, yep, it appears to be safe to exercise out in Stanton, Virginia today. The current temperature is, and now it's getting this information correct, which is awesome. So it's not 50 degrees outside. And we can keep going around this loop if we continue to like hit searches if it needed to do searches, depending on how the conversation is going. But yeah, that's kind of it. There's a whole lot more that you can dig into here. And these are a couple of the resources that I think I wanted to point people at. So many of the good ideas. Oh, this is preventing me from doing stupid stuff while I'm at work, like watching videos. So, yeah, this first video is Inner Cosmos. Really excellent resource. This is just a fantastic talk about with David Engelman about like how to think about AI. Talking with another professor, somebody that's Allison, who's involved with child psychology and child development, and looking at the difference between how AI is developed and how the human brain develops and how we develop as children. It's a great talk. And even more important is this talk from Andre Karpathy, that is like so many of the links and resources that you've seen earlier, and like a lot of the logic and the ways that I've learned about thinking about AI are much thanks to Karpathy. So I can't recommend this video highly enough, and I really kind of anything that this man kind of like takes the time to explain out, he does a beautiful job of it. So yeah, that's it. That's my talk. I really hope that this like helped clarify for you a little bit like how LLMs work and what's going on inside them, and what they're doing. And yeah, that's it. I don't know that I don't want to comment too much more about it, but I'd love to hear your thoughts and responses to this demo and to like the information that I've displayed. Are you thinking differently about it? And what do you think? Like, what do you think LLM should be used for? Should they be making decisions? Like, should they be replacing jobs? Like, what is the right application of this really, really powerful tool? We have this sharp knife. What do we do with it? Thanks so much for listening.